Hey guys, Dr. Brown again with Kubo Math coming to you from Tarlac City, Philippines. I hope everyone's had a great day and now you're ready to perform some integration and then confirm the results by differentiating to see if we end up with where we started. So let's get after it. Remember back in the differentiation, we had a function ax to the n, so we could perform the power rule, the general or the simple power rule. By taking the derivative, we would bring n down, ax to the n minus 1. And that would be the derivative of that function. And you know, if we were to integrate each one of these, now we're taking that function ax to the n minus 1 and we're adding 1, and then we're dividing by that n minus 1 plus 1. Whatever our results were, we're dividing by that. Well, n minus 1 plus 1 gives me n. So the results here, n minus 1 plus 1 is n divided by n. That goes away, it's 1. 1 times n minus 1 plus 1, that's n. So I end up with the original function, which is what I wanted. So that's what we're going to do. We're going to integrate a problem, then take the derivative of it to see if we can get back to where we started. So let's see what happens here. Okay, we have a problem, the integral of x plus 7. Remember, in the differentiation of a sum or difference rule, we had the derivative with respect to x of f of x plus g of x. We had that derivative of the sum. It was simply the sum of the derivatives. That's a g. Okay, so f prime of x plus g prime of x was the same as the derivative of the sum. It's similar that way in integration. I can really say that's the integral of x dx plus the integral of 7 dx. So if I do that, you know the rule, x to the first plus 1 equals 2. I divide by 2 plus 7, and the integral of dx is x. So I end up with 1/2 x to the second power plus 7x plus c. Recall, there's a constant of integration, and actually we'll work a problem later in this video to show you why you do that. Okay, now let's take the derivative of this. So let's say, if that's y, now we're going to take y prime. Derivative of that, 2, bring that down to the 1/2, x to the 2 minus 1, plus 7x to the first, bring that down, and then subtract 1, which is x to the 0. The derivative of that constant is 0. So these two cancel. X to the 2 minus 1 is just x to the first power, or just x, plus 7 times x to the 0. Any number raised to the 0 power is 1. So 1 times 7. So x plus 7 is what we started with. Wow. So yay to us. Okay. So 1 down. All right, let's take the integral of 2 over square root of x dx. So let's rewrite this. Let's do two things. One, you recall the constant multiple rule for differentiation. That applies here also. 2 times the integral of something, or this 2, I can pull the 2 outside like this and say now I'm taking 1 over square root of x dx, which is 2 times the integral of x to the negative 1/2. You know, square root of x is equal to x to the 1/2, but since it's in the denominator and I bring it to the numerator, I have to put the negative sign. Actually, if you think in your mind, this 1 really could be x to the 0. And I have x to the 1/2 down here. Okay, remember the rule, a to the m divided by a to the n equals a to the m minus n. So if I perform that here, x to the 0 minus 1/2, which is x to the minus 1/2. That's where that comes from. Okay. Now, I've got my differential. So let's see what we have. 2 times x to the minus 1/2 minus 1, I'm sorry, plus 1 because we're integrating, plus 1, which is 2 over 2, and that's a positive 1/2. So now I have to divide by 1/2, which is the same as multiplying by 2 over 1. So 2 times 2 is 4x to the 1/2 plus c. Now let's take the derivative of that. So that's y. I want y prime, and that's 1/2 4 times x to the 1/2 minus 1 plus the derivative of the constant, which is 0. 4 times 1/2 gives me 2x to the minus 1/2. So 1/2 minus 1, or minus 2 over 2, x to the minus 1/2 equals 2 over x to the 1/2, which is 2 to the square root of x, which is what we started with. Okay? So we took the integral, then the derivative to confirm the results. Well, we're 2 for 2. All right. Let's take, what about this guy? 8x cubed minus 9x squared plus 4. We're going to integrate that dx. Well, as we stated earlier, we can integrate these individually. Let's just do it here. We have 8 times x cubed plus 1, and that equals 4, divided by that 4, plus, minus 9x to the 2 plus 1, which is 3, so divide by that 3, plus 4, and integrate a constant, just 4x. So 8 divided by 4 is 2x to the 4th, minus 9 divided by 3 is 3, x to the 3rd, plus 4x plus c. Okay, that's y. Y prime then, 4 times 2 is 8x to the 4 minus 1, which is 3. 3 times 3 is 9, x to the 3 minus 1, which is x squared, plus 1 times 4, which is 4, x to the 1 minus 1, which is 0, x to the 0 is 1. 1 times 4 is 4. Derivative of that is 0. So 8x cubed minus 9x squared plus 4. Okay? Maybe it's better if I write down more of the derivative steps. What would we do with this guy? X squared plus 1 squared dx. Well, probably the easiest thing to do would be FOIL that, which would give you an array of terms, and you could integrate each one. So x squared plus 1 times x squared plus 1, and that equals first times first, x to the 4th, plus outer times outer, plus x, so 1 times x squared is x squared, plus the inner, which is 1 times x squared, which is x squared, and then last plus 1 times 1, which is 1. So x to the fourth plus 2x to the second power plus 1. Okay, so we have the integral, the integral of x to the fourth plus 2x to the second power plus 1 dx. Okay, now then, x to the 4 plus 1 is 5. So I multiply that by 1/5 or divide by 5 plus 2x to the 2 plus 1, which is 3, divided by 3, plus integral of 1 dx is x. So I have 1/5 x to the 5th plus 2/3 x cubed plus x plus c. Okay, we'll call that y. Y prime then, 5 times 1/5 x to the 5 minus 1 plus 3 times 2/3 x to the 3 minus 1 plus 1 times x, which is 1, times x to the 1 minus 1, which is x to the 0 plus 0. So I ended up with this 5/5 x to the 4th plus, these 3's cancel, 2x to the 3 minus 1, which is 2, plus 1 times x to the 0, which is 1 times 1, which is 1. X to the 4th plus 2x squared plus 1. And if we factored that, we would end up with x squared plus 1 parentheses squared. Okay? So far, so good. All right, what about this guy? X cubed plus 3 over x to the second power dx. Ooh. Well, since we have a single term in the denominator, we can put that under each, separate the terms out. So that's x cubed divided by x squared plus 3 over x squared dx. Okay. Well, you know the rule, we mentioned it earlier. A to the m divided by a to the n is a to the m minus n. So I have, in this case, the integral of x to the 3rd minus 2 plus 3 times x to the negative 2. We'll bring that one up, dx. And that equals the integral of x dx. So that's x to the 1st power plus the integral of 3x to the negative 2 dx. I'll pull the 3 out. Okay, now that equals x to the 1 plus 1, which is 2, divided by 2, or multiplied by 1/2, plus 3 times x to the minus 2 plus 1, which is minus 1, and I'm going to divide by minus 1. So that's 1/2 x to the 2nd power minus 3x to the minus 1 plus c. I guess I need to move this one up here. So 1/2 x, write that larger, 1/2 x squared minus 3x to the minus 1 plus c. That's y. And we want to take y prime, which is the derivative of that. That's y. So y prime then equals, bring the 2 down, 2 times 1/2 x to the 2 minus 1. Now bring 1/2 or minus 1, excuse me, minus 1 times negative is plus 3x to the minus 1, it's minus 1, plus the derivative of the constant is 0. So what do we have left here? We have y prime equals x to the first power plus 3x to the minus 2. Minus 1 minus a positive plus a negative. So minus 2 plus 0. And that is x plus 3 over x squared. If I get a common denominator of x squared, so multiply this by x squared, that's x cubed plus 3 over x squared, which is what we had. So it's confirming that all the calculations are correct, and the derivative of the integral gets back to where I started. So it's a great confirmation tool that the calculations are right. So when you can, I would encourage you to integrate, or after integration, to differentiate to see if it's correct. Now you can't do that all the time because some problems we'll get into in the future are very complex. But for now, this works out okay. It's not that difficult. Now it may be the first time you see it, as it was for me. I'm like, what the heck are they talking about? Okay, all right, let's work one where we have a derivative defined. And let me get a new pen. See if this one's better. All right, so let's say f prime of x equals 3x squared minus 1. Now let's also imagine we have initial conditions where we're saying f of 2 equals 4. Now f of x equals the integral of f prime of x dx. Okay, so having said that, f of x then equals the integral of 3x squared minus 1 dx. Okay, so let's integrate that. So we have 3x to the 2 plus 1 equals 3. Divide by that 3 minus integral of 1 dx is x. So 3 over 3 cancel, and I end up with x cubed minus x plus c. Now in the spirit of everything we've just done, let's integrate that, or take the derivative of that to see if we get back to our original function. So bring the 3 down, x to the 3 minus 1, and then bring the 1 down, x to the 1 minus 1 plus 0. So this would be 3x, 3 minus 1 is 2, minus 1, 3x squared minus 1. Yes, so that put us back to, we know our integration was correct because we went back to the original problem. So let me erase this. So that's f of x. Now we have an initial condition that says when x equals 2, the results of this equation equals 4. So f of 2, so it's saying that everywhere there's an x, insert a 2. And that's going to equal 4. So 2 cubed minus 2 plus c equals 4. So 4 equals 2 cubed is 8 minus 2 plus c. 4 equals 6 plus c. So I subtract 6 from both sides. It gives me a negative 2 equals c. Now I can take that value, plug it back into this equation. So now f of x equals x cubed minus x minus 2. And this is a particular solution. If you have the initial conditions, you can solve then for the particular solution of that equation, of that differential equation, get it down to a full equation, if you will, but it's called a particular solution. That's why the plus c is important. Let's say I have some function that's x squared. You know, we know it looks like that. Maybe it ends up being x squared plus c. What if c ends up being 8? Well, that means my function is moved up here. When x equals 0, I'm sitting up here at 8. Y equals 8. So that's why, based on c could give you a family of curves for different values of c. So that's just an insight as to why we have the constant of associated plus c on all the integrals. So, okay, I think we'll stop there. Hopefully you've enjoyed this video. We wanted just to practice the simple integration, confirm that by differentiation, just to get some experience under our belt on solving some problems. So we'll continue with future videos, the rules of integration, and various other things in the future, but hopefully you've enjoyed this. Remember, study, study, study. I'll say it every week. Study the rules and practice as much as you can. So together, let's build a better tomorrow, and let's do that through math. So all for now. We'll talk to you again soon. Thank you.